The series of an arithmetic sequence of numbers is actually the sum of the listing of numbers. So series and sum goes together. In fact, it's often called the partial sum. And so to find the formula of the sum or of a listing of numbers that are arithmetic means that you're basically going to add up all the numbers. Now, if I started with the sum, S sub n, and listed all the numbers that I'm adding up, and then reversed the order, and then added them down, you're going to see that the first term plus the last term is really equal to the second term plus the second to last term, and the third term plus the third to last term. And since that's the case, all of these sums are equal, and they equal such as the first and the last sum. They're equal to n number, there are n of these, of those sums. And when you add them down, there are actually two s sub n's. So when you divide by 2, you actually get the first formula. The sum of the first n terms is equal to the number of terms divided by 2 times the first term plus the last term. Now, to get the second formula, you're basically taking your a sub n and you are substituting in the sequence formula, which is a sub n equals a sub 1 plus n minus 1 times d, and that's how you end up with 2 of those. But I think I just keep them separately, and this formula and the sequence formula to solve the problems that you need to. Let's go ahead and solve the first one. What is the sum of the first 82 terms of this? The question is, well, what's the total number of terms? N is 82. What's the first term? 1. And I don't know what the last term is. So off to the side here, I'm going to say a sub 82 is equal to the first term plus n minus 1, which is 81, times the common difference, which is negative 3. I'm decreasing by negative 3 on each of those. So it's negative 1 minus, and let's see, this is going to be 243, which means that the 82nd term is negative 244. So that's going to be minus 244, or plus a negative 244, which means that this is going to be 41 times a negative 245, and the sum would equal that answer. Now, if the nth term is given, such as in the second one, and the question is what's the 25th sum of the first 25 terms, you could just directly substitute it right into this formula and solve. So that's really not too bad, and so those are two of the problems that you encounter. But this last one is a little bit harder, so I want to spend a little bit of time on that one. The question is, well, let's do 6 and then come back and do 5. The question is, how many terms are there from 1 to 42? And the answer is your total number of terms, n, is equal to 42 terms. Now, unfortunately, they use an n here. It'd probably be better if they did a k, because n represents the number of terms that I'm looking for in the formula. All right, so basically all you have to do to find the sum of the first 42 terms is substitute it into the formula. So the first term is where k is 1. I put 1 in for k and I get 2. So there are 42 terms. The first term is 2, and the last term is going to be 2 times 42, which is 84. And that's divided by 2, and so then you can just have the sum on that one, which is that number right here. Now, if I go to number 5, number 5 has a difference here. It's starting with n is equal to 3. Now, n is equal to 3 means you're starting, your first term is really where n is equal to 3. So when you plug 3 in, that's your first term. The question is, what is your n going from 3 to 15? Now, the answer, a lot of students will want to do is subtract 15 minus 3 and just call it good and say it's 12. But it's really not 12, it's 13. You can count them on your fingers if you don't believe me. The formula is you subtract the numbers and add 1. Why is it that way? Because if you subtracted 15 minus 3, you're getting the number of differences, not the number of numbers that you are subtracting. So if you subtract and add 1, you get 13. Now you know what your n is. and you plug this in to n and get your 3. So again, I prefer this being k instead of all being n. So the sum of the first 13th terms is equal to, and now when I substitute, well, I'm 13 n divided by 2, first term is going to be 10 when I substitute 3 in for k, and 46 when I substitute 15 in for k. So that sum is going to equal 6.5 times 56, and you get your answer. So be very careful where this starting number is not equal to 1. You have to remember, subtract the numbers and add 1 to find your total number of numbers. So what I did here is I basically used the series formula and found out what the sum is of all these terms.